Alright, today you're going to work on solving equations with exponents and logarithms. Yesterday we worked on solving equations when the log is already in the problem. Today we're going to work on solving equations when only exponents are in the problem. Okay? So there's two ways to go about this actually. Okay? A and B. The first way to go about this is by rewriting the problem in logarithmic form. Okay? So let me show you what I mean. Let's rewrite this problem to logarithmic form. If we rewrite this problem in logarithmic form, we get log base 4 of 1024 equals x. Okay? Now, in previous years, this has been a huge problem. And we had to go off on this big tangent. But with our calculators nowadays, we have that's not what I want. Okay. We have a calculator that we can put in log base 4 of 1024 and see that the answer is 5. So x equals 5. Okay? The problem is I can't always promise that you're going to have this kind of calculator, so I need to show you the tangent we would have to go off on. And that tangent is called the change of base formula. Okay? The old calculators, even the old blue and yellow calculators that we used to use here at the high school, wouldn't do this. It's only these brand new calculators with this kind of faceplate on it that will do this for us. Okay? So I don't know where you're going to go to school. I don't know, first of all, if they're going to let you use calculators or things like that. But when we're doing logarithms, if you get a base other than 10 or e, you have to use what's called the change of base formula. Your calculators, even the old calculators, would do base 10 and base e. This is log base 3. Okay, so the old calculators wouldn't do it. So we'd have to do what's called a change of base formula. Change of base formula says I have to take the log of the argument and divide it by the log of the base. Okay, and some people don't remember what to divide by. So I'm just kind of giving you a hint right now. Whatever the base is, that's what goes in the base of the fraction. Is that a good way to remember it? Hopefully so. Okay? But what base is this log right here? Well, the base of this log right here, since it's not written, is 10. And we do that on purpose because that's a base that the calculator can take. So let me show you this real fast. If we do log of 4 divided by log of 3, I get 1.26186. 1.26186. Now, with our fancy calculators, I should just be able to do log base 3 of 4, and guess what I get? Oh my gosh, it's the same thing. Okay? Once again, we can do log base anything we want because of these calculators, but I don't want you to get into a situation where you don't have one of these calculators and don't know what to do. If our log is anything other than base 10 or base e, I want you to know the change of base formula, and that's the log of the argument divided by the log of the base. Okay? So look at a problem like this, log base 4 of 4096. That would look like log of the argument, which is 4096, divided by the log of the base, which is 4. So in our calculators, we'd say log of 4096 divided by log of 4. 6. Just to make sure, log base 4 of 4096. 6. Okay? Change of base formula in this one would be log of 1 over 81 divided by log of 3. Log of, I'm going to give myself a fraction here, 1 over 81 divided by the log of, whoops, not that, especially not that, delete log of 3, negative 4. Okay. Again, just to check because we have the capability to check. 1 over 81. And sure enough, it's negative 4. Okay? But what about a problem like this? This is not a problem we can check in our calculator, so we really have to know the change of base formula here. Log of x divided by log of 4. Okay? So there's some problems on the bottom of your worksheet right down here with the change of base property. That's why I'm having you do the change of base property rules. Even though it's not required of us right now with these calculators, it may be in the future depending on what kind of calculator I have to use. Okay? So some other problems. If we have a problem like this. The one that we just did a minute ago was easy because the base was already isolated. The base where the exponent is, that's already isolated. Normally when we solve equations, we isolate the x. Okay? We do all the inverse operations that we can to get everything away from the x. That's still what we're doing here, except in places like, in problems like this, the base is not isolated. So before I can start writing stuff in logarithmic form, I have to isolate the base. Here, the way I'll isolate the base is divide everything by 3. When I divide everything by 3, I get 0.25 to the x power equals 10. Now, is the base isolated? Is anything else being added, subtracted, multiplied, or divided from the base? Hopefully you will see that the answer is no. So now once the base is isolated, then I can write it in logarithmic form. Because really, think about this. I have to do the inverse operation, which is divide, to get this 3 away. Once the base is isolated, I still have to do the inverse operation because of the fact that the variable is in the exponent. Okay? The inverse operation from exponents is logarithms. Right? So I write this in logarithmic form. Log base 0.25 of 10 equals x. Now we can choose to do the change of base formula if we wish, because that is something that I want you to know how to do, or we can use the technology that we have available to us. So in this case, x is going to equal negative 1.66096, because that's what it says here. Okay? So what about a problem like this? I have to isolate the base. So what's being done to the base right now? Well, if you see that 20 is being added to the base, so I have to get rid of the 20. If I subtract 20 on both sides, I end up with 3 to the x power equals 31. Base is isolated. Now I have to put it in logarithmic form because that's the next step to do the inverse operation of it. Log base 3 of 31 equals x. Once again, I can choose to do the change of base formula, or I can just use my technology. And I get an answer of 3.12575. Now, something I've forgotten to show you on the first two problems is, once again, I should never get any of these wrong, because I can go back to my calculator and say 20 plus 3 raised to the 3.12575 power. Substitute this answer in for x, and I should get 51 or something really close to it. In this case, I know that that number was exact because I got exactly 51. Okay? On these other two problems that we've already done, if I take this number and plug it in for x, I would say 3 times 0.25 raised to the negative 1.66096 power. Now look what I get. I got 29.9998. I should have gotten 30. So what does that tell you about this answer right down here? Hopefully it tells you that that answer was rounded. Okay? Is this close enough to be the answer that was given to say that this is a correct answer? Since we know that this is a rounded number, hopefully you see that this answer in the calculator is close enough to what we should have gotten. Okay? One more example and then I'll let you go on the worksheet for homework. Okay? Here's the problem. We have to isolate the base. There's a lot going on here, so don't get distracted. Okay? First thing I need to do with isolate the base is to add 3 to both sides. Just like any other equations, I got to add or subtract first to get so that I'm isolating what I need to isolate. Okay? Now I do my division. 0.06, 0.06. 103 divided by 0.06. 1716.67 is what that equals. 5 to the x plus 1 power. Now, is the base isolated? Sometimes people are confused by this because there's still a plus 1, but please notice the plus 1 is actually in the exponent. So if we're finding out if the base is isolated, the answer is yes, the base is isolated. Okay? Since the base is isolated, I do the inverse operation of the exponents, which is logarithms. So I say log base 5 of the argument, which is 1716.67, equals the exponent, which in this case is x plus 1. Okay? So I do my log base 5 of 1716.67. I get an answer of 4.62779, but that equals x plus 1. So to actually solve for x, I do have to subtract 1 from both sides. So x should equal 3.62779. Right? Is that the correct answer? Well, come back up here. 0.06 times 5 raised to the 3.62779 plus 1 power minus 3. What should that equal? It should equal 100, and it does. Okay? Please work on the problems on the rest of your worksheet, including these 8 down here at the bottom, and including these 9 on the back. Okay? Hopefully you'll be okay with these. Okay? Read this example up here at the top. It's very clear on what to do. This, however, is showing you a different way to do change of base formula. So I would actually rather you concentrate on the 8 on the bottom and the 9 on the back. Those are the ones that I will be checking when I get back. There is a bonus problem at the bottom. Work on that one if you wish. Okay? These review problems do not do yet. The review problems on the back of this page, do not do these yet. Remember I had you tear off a piece of paper the other day that said review problems, and what were those for? Do you remember? They're for Monday. These problems we are also going to do on Monday. So the only problems I'm checking for you when I get back on Monday are these 9 on this page and the 8 on the bottom of the front page. And the bonus if you want to do it. Okay? Everybody clear about that? Okay, I hope you have a great day. Please behave and be polite to the sub.